and I'm here today to talk to you about the application of machine intelligence in space education. First, I'm a part of a team called the Wolfpack CubeSat Development Team. And what we do is we're a group of middle school students that design, build, test, and launch CubeSats, typically with either a biological or other payload. We also participate in a number of other activities, such as presenting at international conferences, participating in educational outreach, and working with policy and legislation leaders. So first, what exactly is machine intelligence? Machine intelligence is a program's ability to adapt and respond to certain situations. It's found in almost every commonly used software today, from self-driving cars to Siri on your phone. And there are actually multiple kinds of machine intelligence, the most well-known being AI and machine learning. Machine intelligence runs on two main computational theories, the theory of computation and machine learning theory. The theory of computation is concerned with how problems can be solved with algorithms and how efficiently this can be done. And machine learning theory is focused on understanding the fundamentals of learning as a computational process. Machine intelligence is important for space missions because efficient and intelligent code is vital to the success of space experiments. Machine intelligence plays a role in almost every professional aerospace technology, from autonomous vehicles to image processing. I'll be covering a few of them in my presentation, but I'll be focusing on the educational aspects of this. Here's an example. Machine intelligence is heavily employed by organizations such as NASA, and is using tools, mainly those that are software-based, that help them design and build their experiments. AI software runs some of the most important experiments in space today. For example, Mars rovers run completely autonomously with artificial intelligence software. In 20 minutes that it can take to communicate with Mars, a lot can happen to a rover. It can be damaged or stuck somewhere, and it's important that artificial intelligence is making good decisions and keeping the rover safe at all times. In addition, in a conference around 2 months ago, I got the chance to speak with the person who actually managed the sample analysis portion of the rover. He explained the logistical challenges associated with bringing back a sample to Earth, meaning that it's important that the rover can automatically analyze samples that it collects on site. In addition, manually operating a space experiment is extremely expensive because of communication and 24-hour monitoring. Because of this, especially student space teams have to rely on automatic software to run their experiment for them. Here's another example. Right now, there are about 34,000 objects the size of a grapefruit, about 4 inches, that are threatening existing space infrastructure. For reference, a single grain of rice-sized object in space can completely destroy a CubeSat. A grapefruit, a larger object like that can cause major damage to even the ISS. In this field, machine intelligence is used to determine the type, path, and capabilities of space objects, keep a catalog of known and observed objects, monitor the probability of collision, and determine the best course of action to avoid damage. Here's another example. Right now, commercial imaging companies already have more than 400 petabytes of satellite imaging data collected. This is equivalent to all books ever written in every language combined. The real value in this lies in turning raw images into useful data and insights. Machine learning here is key in finding and categorizing objects, identifying trends, extracting meaningful data, and supporting machines with visual sensors. A few years ago, some machine intelligence software was actually able to discover thousands of new stars based on trends taken from images of space. Also, cloud infrastructure tools are available for space teams. Companies provide cloud computing and pre-trained AI for a large variety of tasks, and they're used widely by professional space teams such as SpaceX and Starlink. Also, students are able to use these software for their missions. There are also intelligent tools that simplify the process of creating these kinds of intelligent software that help students really work with these kinds of things. Now let's focus on the educational aspects of machine intelligence. artificial intelligence specifically is very useful in the classroom. According to McKinsey, only 49% of a teacher's time is spent in direct interaction with their students. That's less than half. What AI brings to education is it helps automate some of that 51% by doing automatic grading and even curriculum preparation, so teachers have the ability to spend more of their time with students. AI also brings some other useful features for students, such as learning personalization, instant feedback, and 24-hour assistance. Now let's take a look specifically at space education. This is the journey that every student space mission follows as it develops. This is how our team, the Wolfpack, goes about things as well. In the planning phase, students have to design the mission, perform some 3D modeling, and get funding approval from organizations such as NASA. And here, machine intelligence helps with design choices, CAD software, and writing assistance. During the design phase, students have to design the experiment, perform some 3D modeling, select components, and build and test their CubeSat or other space experiment. Here, machine intelligence is used in the testing sites to determine if the hardware passes certain tests like vibration or temperature. Also, machine intelligence can optimize component choice and costs. Most importantly, in the mission phase, students have to monitor the experiment, collect and log data, and communicate with their hardware. Here, machine intelligence helps by running the experiment autonomously, processing and organizing data, and managing power and communications. Finally, during the analysis phase, students have to analyze data, draw conclusions, and write final reports. Machine intelligence is key in data analysis, organization of data, and helping with writing as well. As I mentioned earlier, the Wolfpack participates in educational outreach activities. For example, we're currently organizing a hackathon for students in India to learn programming and teaching students with no prior experience with community centers. What machine intelligence brings here is it helps lower the barrier of entry for students to participate in our activities. Here's an example. Microbits are small computers about this size that use very simple block coding and are designed for beginner programmers. The microbit takes the students or beginner programmers very simple block programming and uses intelligent software to kind of fill in the gaps where more advanced syntax would be needed. With this approach, we're able to bring what we do to students all across the world, even if they don't have any prior experience. In addition, as I mentioned earlier, machine intelligence is useful for mission planning. Intelligent software can be created and used to run simulations to ensure mission success. There's software that can predetermine mission conditions if calibration or anything like that is needed. Also, the Wolfpack launches frequent piloted balloon missions as practice for our big CubeSat missions, and we use software to determine if a launch window is ideal. Also, software can be written to anticipate CubeSat results if data is needed. Since I've spent the last few minutes talking about the benefits of machine intelligence in space education, here are some of the challenges associated with it. Even minor errors with intelligent software can completely compromise an entire mission, and machine intelligence requires higher-end hardware to run properly. In addition, ionized particles can cause changes in a computer's power system, bit flips, and power burnouts. Basically, ionized particles can make changes in the computer's electronics that cause problems with running reliably and functioning properly in space. Despite this, the risk can be almost completely mitigated via radiation hardening, data checks, and thorough software and hardware testing. So, what's next? Machine intelligence with more advanced capabilities will become more available because of simplification and general more ways to work with it, which will make it much easier for students and other people to work with it. In addition, existing technology will reach a broader part of the population as more people gain access to computers and such devices. In education specifically, the features that I mentioned earlier will over time be implemented. It takes time, especially with existing systems, to implement new technology technology and change old habits. In the end, intelligent software has and will continue to revolutionize this field. Thank you. If you have any more questions, I'll be happy to answer them after the